All right. Welcome back to another EV Hangout episode. This is where the rising tide lifts all boats. This is where we share the ideas of EV conversion. Tonight, we got some special roundtable guests, and the topic is going to be the pregame for the State of Charge show out in Colorado. I'll be there. Rocky's going to be there. I think some other people will be there too. And also tonight, we're going to talk about wiring diagram. We're doing 2 conversions here, just a Hyper 9 conversion. And then also we have a special vehicle, and I think some other people in the crowd here have some special vehicles that we could talk about. So we're so lucky to be joined. We got a co-host, Talik. How you doing?
We got ReVolt Systems here in the house. We have Mr. Snow here. Say hey, Snow.
Hey, how you doing? This is Snow from ReVolt Systems. So we're going to be doing something for State of Charge also. We'll talk about it in a second.
All right. And don't forget to check out their channel, Gas and Go with Snow.
And
ReVolt Systems.
ReVolt Systems on YouTube too.
Nice. All right. Snow, what's happening in State of Charge? Tell us what's happening.
Okay, well, I'm sure you guys already know. State of Charge, I want to say this is their 3rd annual, conference. And for our portion of it, what we're going to do is right now, you can see behind me, we have a 1936 Cord Phaeton that belongs to Simple Green, right? And what they want to do is they want to electrify this car. So we took on the task of electrifying it, and part of the State of Charge is they're going to have a live feed from here at ReVolt Systems, and we're going to go through how we're electrifying this vehicle. So it should be pretty interesting if you're into this electric conversion stuff.
Especially if you ever want to do thing front wheel drive, because this thing is pretty unique that way. Yeah.
So this is unique. And one of the things that we're going to be showcasing, I don't know how many of you guys follow ReVolt Systems, but we don't just make a motor kit. We have the motor kit. We have a divorced inverter setup. We have the that coolant delete kit, and we have a full-on contactor box. I think they also call it a junction box. So we have all these new products, and I believe everything that we've come out with is going in this car. So it'll be informative to say the least.
Wow. And that's such a special car. The Cord, is it 1929? I can't remember.
36. So 1935, the Cord came out, and this car, this particular one, it had the supercharged motor. It was an airplane motor. And what the guy, it was a young engineer. He was only like 22, 23 years old. And this car was a first for a lot of automotive advancements. Like, it has pop-up headlights. The first car to ever.
Come on. That's the most important part. Come on.
Absolutely. And as you know, this coffin nose hood, it has that split windshield. So, and it's the first front wheel drive car to ever be made in America. So this car is definitely a piece of American automotive history.
Nice. And I just want to mention, joining us is Jehu Garcia, Jag 35. How you doing? What's happening, Jehu? Oh, you got to unmute it.
Hey, Jehu.
All right. You'll figure it out. Anyway, Tom Summers is in the house as well. Another V-dub man.
Hey, I just heard somebody mention split window.
No, for the Cord, not for the V-dub.
Yeah, I know.
Anyway.
Anyway, those cars are really famous.
Dave's doing a Beetle, but he also has the Thing. Right?
Totally want one of those things. That's my next car that I want to get.
I want to convert it. Once I do the Bug, I got to get the Bug finished because we drive the Thing now. It's gas. It's nice.
Wow.
So
Cool.
Ron, so we got kind of a little primer from Snow on what State of Charge is. Let's tell everybody a little bit more about State of Charge, and then Kevin had his hand up. Unless Kevin's got some charge.
Let's go to Kev. Oh, you got to unmute.
You're going to convert this Cord to electric fully at the show, or
no?
What is the
in
deal?
the middle of the process, right?
Okay.
Yeah. No, we'll be revealing the process, showing what needs to go in, showing the progress. But no, it won't be finished and fully converted during the State of Charge show.
And is that only available to those attending State of Charge? The live? Okay, so yeah.
Got it. That's so exciting. I can't wait to be there. Basically, State of Charge is kind of like this, but all the people are going to be there live. It's kind of an in-person version of this, what we're doing here. And is someone over there? We got people coming into the shop, so that the dog's barking. There is a guy across the street. I'm hoping he comes over here. He wants to do a ReVolt system on his 240Z.
Oh,
Funny.
oh yeah, oh yeah.
Yeah, I know. Let me see if he's over there.
Speaking his
Try and
language
grab him,
here.
that'd be really cool.
Dude, that thing would be a rocket with a ReVolt motor in it. I don't want to get distracted. Go ahead, State of Charge.
And it's already, well, we'll send this video to him to get him all psyched up. It's already a dragster. He's got like huge tires, rebuilt subframe underneath, and it's got I think a Chevy 350, and he's done it with nitrous and without. You know, and I can't remember what he's running, but he's into it. He wanted to get the plaid, and he bailed on the plaid. That's it right there. There's Abe. Tell Abe to come over here. He doesn't even know you, but just he'll know. He'll know what's going on. He's just walking by. I knew I'd see him. So anyway, so he wants to convert it, and so he's like, "What if I, instead of buying a stock, car from Tesla, why don't I just convert it?" I was like, "Dude, I think I know the perfect system. You got to talk to ReVolt." There you go.
Yep.
Pretty cool. So so what else is happening at State of Charge? I think Legacy is going to be there to teach. Is that right?
Yep.
That's cool. And but I don't want to waste Snow's time. If you're leaving soon, what else you got to show us? Anything crazy at the shop there?
Well, I can show you our new shop toy.
All right. That would be
All right.
cool.
Go ahead and keep talking about State of Charge, and I'm going to pull up.
All right.
He's gonna-
Okay.
he's
That
gonna
sounds cool.
play around.
Okay. Talik, if you want to pull up the State of Charge website, if you're on a laptop, and then
Okay.
you could share the screen, we could look at all the speakers because there's a lot of good ones. Even one of our own who took the EVLC class and has been part of this podcast a few times. That's Sarah Lyon, and she has done a Suzuki Samurai Hyper 9 situation. She'll be at the show. That was her first conversion, and she's not done yet, but she's working on it. Pretty cool. And just going around the room, Jayho, you got anything new for us going on? Are you going to State of Charge?
I haven't decided yet. I know. I mean, it's coming up, so yeah. I don't think I'm gonna be able to make it.
No
Yeah.
problem. So there's a list of speakers at State of Charge. I think it's gonna be a good time. Terry is working his butt off right now, he's converting a Corvair.
Nice.
Yeah, but he's using a Maverick EV motor, which is kind of like a small Tesla drive unit. And then I think he's using amp batteries, an amp system. I actually don't know. We got to check it out. I can pull up the website and whatnot. But in the meantime, let's go over to Chris is going to be there. Chris, what do you expect out of State of Charge? Okay.
Yeah, I mean, I haven't been there before, obviously, but I saw all the different speakers. I think some of the topics are going to be super interesting, like especially the one where they're talking about, I forget who's presenting it, but there's one that's talking about beyond just the one-off builds, where you're kind of specializing in particular vehicle platforms and especially in focusing on that. I'm pretty excited to learn about that one.
Nice. And here it is, and we could pull up the lineup here, unless Snow's ready. Then when they come back,
we're about ready to go. I was trying to find the website. I could only find the SOC 23. What's the website
no,
for
I
this?
got. Okay,
What-
this is ohmontherange.org, and then but it's cool. I brought it up. We're good.
Okay.
So we're going to go through this. So Felton's going to be there. They're kind of like big company coming up. Actually, ReVolt Systems, Matt Deely is going to be there. The Wheeling Welshman will be there, and behind the scenes, we're going to have some great people there. It's going to be awesome. I want to see that Lotus Esprit. Oh man, this is going to be such an awesome show. This is a killer show. But in the meantime, let's first get over here. Okay, oh my God, what is that thing? Snow, give us the intro of this.
All right. Well, if you look at it from the front, this is a 1992 Humvee. This is an actual combat vehicle. I picked it up from Brian over at Current, and this is kind of our new shop truck. So I'm daily driving this thing, and it is so much fun. 37-inch tires, custom wheels. They got razor seats, and then it's cool. I am 100% disabled vet, so people see this thing coming down the road and look on the windshield.
Oh, it's funny. The handicap thing. Oh my God. Dude, what's down the middle? Is that just the transmission? It's huge, right?
Yeah, the transmission tunnel, it's huge, but it's the transmission, the transfer case, and for an actual military application, this is where all your communications and all your accessories and stuff in the truck would be. And in the back, you would have your gun turret and a 50 cal sitting up here.
Oh my God. Oh my God.
And
what's it under? Oh yeah, AM General. Right, right. Is that who originally made the Jeep as well, or no?
No, Jeep made the Jeep, and this is what took over for the Jeep. It was a more purpose-built vehicle, so it was a little more rugged than a Jeep.
And am I right? You can lift it up with a helicopter because it's got lift points.
Yes. So this right here, these lift points, this will pick the whole truck up. One of these will lift up the whole truck. So there's one here, one there, and there's two in the back.
Oh my God, that's crazy. What's it like driving it?
About Humvees, I learned all this after I got it. I just started I wanted to know everything about a Humvee.
Is that, and that's am I right? It's like a diesel truck, like a 24 volt system, right?
Yes, it's a 24 volt system. It's a 6.2 liter GM diesel.
Nice, dude. What's it like driving it?
Oh, I love it, dude. This thing is over 7 feet wide, so it tracks amazingly. And I got 16.8 miles a gallon going to San Diego.
So if you want to know what it's like to drive, we're going to have some driving footage soon on Gas and Go with Snow's YouTube channel.
Nice, nice, cool. Dude, that's awesome, man. What a cool vehicle. Like, I think people overlook it, but that is actually probably relatively lightweight for what it can do. It's so capable.
5,200 pounds, so it's lighter than a Tesla.
That thing's 5,200 pounds?
5,200 pounds.
That's way lighter than I thought. That's actually pretty light.
It's missing doors.
It's missing batteries. Hey, it's missing the doors. Abe says, where's the doors?
We don't need no stinking doors.
Okay, I want to introduce you.
I don't need doors.
Nice. I want to introduce you to Abe.
Hi, how are you guys?
Abe, tell us about your car, the 280Z that you're going to put a ReVolt in maybe. Let's see.
I have a 280, a 77 280Z. I converted it about 15, 20 years ago to a V8. Small block Chevy, nice and simple. But ever since 2013, when the Tesla Model S came out, I fell in love with the car. And I've just completely converted. I'm still a motorhead, don't get me wrong, but electrification is where it's at right now.
Nice, nice.
And the ReVolt is definitely something I'm interested in for that car.
What's in the rear? It's a 9-inch rear?
It's an 8.8-inch Ford rear end with 9-inch ends and 33 spline axles and a spool. So
all right.
Basic drag racing stuff.
Yeah, cool, cool. Actually, we can go over there if you want to show us. We could show it maybe, and we could talk about how to fit the ReVolt system in there. That would be pretty cool.
Sure.
All right. I got my phone. We'll go over there a little later.
Sure, no problem.
Okay.
Get it ready, man.
To answer your question, the ReVolt system was designed specifically for the application that he's talking about. It was designed for a front engine, rear wheel drive car. So you have that small block in your car. So if you look at this, you got motor mounts here, right? And those two motor mounts will go to on the frame rails. And then notice you got your inverter can. Here's the motor, and that right there, that's your torque box. That's going to take the place of your transmission, and your drive line will bolt in right here with a slip yoke, and you can still use a turbo 400 mount. That's what this bolts to, a turbo 400 mount, which you probably already have.
Turbo 400 is what I'm running in that car.
Okay, see, so you don't have to make a ton of modifications to put this in your Z.
Yeah.
Okay,
And
question. Yeah.
Have one of my buddies, Eric Dotson, has an 800 horsepower Z.
Right. Mine only has 500 without the nitrous.
Okay, so without the 500, it's going to be 603, and you're going to have well over 1,000 pound-feet of torque.
So then the only other thing is, how much extra weight is it going to add? I know that the ReVolt setup is 300 pounds, but when you include the batteries, the car weighs, when I was a little bit heavier, 2,700 pounds. Now maybe it weighs, 2,750 pounds. Maybe now it weighs 2,700 pounds.
He's gonna lose weight.
Now, this is general rule of thumb, but this is not going to apply to you. You're drag racing. So what you're going to do is you're going to not going to use Tesla modules. You're going to probably use a prismatic cell. You're going to use a lot less of them, a much higher C rating. You only need to go a quarter mile, right? So you can have a much smaller battery pack. And so general rule of thumb is you electrify a car, add 200 pounds to it because you do use 1,000 pounds of batteries. But for your application, you don't need to do that. What do you think about that?
Well,
He's drag racing a 280.
no, I agree. And then now batteries are getting much lighter. I mean, the prismatics are getting so much higher than C rating. C rating is like the biggest thing for us race guys. What's up, Jehu? Nice to see you, brother.
Oh, everybody, this is Eddie B. ReVolt Systems here.
So so kind of going back to weight on the car, the Mustang is a perfect example for it's a race car, but it's a daily driver, and it's kind of based on some older technology with Tesla cells. That car originally weighed 2,800 pounds. We added 100 feet of tubing to that car of 090 wall chromoly, 1 3/4 inch. So lots of that stuff. We put a chassis underneath that car from Roadster Shop. So all that stuff that we added to it, if we did an LS swap or a Coyote swap, we would have been around 3,500 pounds. That car weighs 3,400 pounds right now, fully up with an 80 kilowatt or 85 kilowatt.
And that's with 900 pounds of battery and 85 kilowatts.
So technically,
85 kilowatts is a lot.
Yeah, it is. It's a big pack. I get over 200 miles out of it.
Yeah.
So that's kind of a really good apples comparison between I took a Resto Mod 65 Mustang and we completely made it into a cool, really, really nice Resto Mod. And the weight ended up to be about the same of where our friends from BNMC and then Big Daddy motor cars, their cars, when they have all this stuff done, they're about 3,400 pounds. So
it's comparable,
pretty comparable. And my balance is great.
If only we knew somebody that knew something about batteries so we could find something to do. Give us a high C rating. Jehu, can you get this guy some high C rating? Come on. What should he run?
Well, there's all kinds of high C. Well, there's not a lot of them actually. There's there's the Chevy Bolt. No, it's not the Bolt. What are the ones? The C-Max. But those are kind of big and heavy, so you can't put 85 kilowatt hours worth of battery and then
No, but he's only drag racing. You're gonna just go to car.
Yeah, there you go. Yeah,
this is what you want to use. That's a prismatic cell. It's NMC, and that is a 3.7 volt nominal, and that's a 50 amp hour battery right
55.
there. My bad. That's a 55 amp hour battery.
That's pretty good.
I do want to get a little bit of range in the car though, because I do want to.
You want to go to LED East?
I want to.
Did you go to LED East, the show?
No, I didn't.
What?
I was working.
Oh, Labor Day weekend, big 50s show out here, and they got
I saw
it's up to 85 now, as you can bring your car.
What kind of range is that? How far is that? Just
it's only
200 miles.
30 minutes. It's 30 minutes from here.
I think if I had 100-mile range on the car, we'd be plenty happy with that.
Easily, you could do that with these prismatic cells. And now you see how big it is. That's my hand. and you see how big it is.
You got a big hand though.
That's
How
how
many?
thick.
Here's a large iPhone.
This is an iPhone.
Got it. Got it.
So
Nice.
with these and a ReVolt system, I'm telling you, man, your Z is going to be. You better hold on to something.
Awesome. Awesome. Super cool. So if you get over there, we can show it a little bit.
Sure. No
I can go over, but first we're going to go over a project and we're going to talk about the mini truck. Okay.
I'll be ready for you.
All right, cool. Maybe
right.
like 10, 15 minutes.
Nice meeting you guys.
All right.
I'll see you in a
you
bit.
Cool. All right. This is good stuff. So I got
Another
the state-
conversion on the making.
Yeah, it's happening. So let's see. I got the State of Charge website up. Let's just go through the list real quick,
Right.
and then we can go into the project here. All right. Thanks a lot, Snow. We'll see you guys. Awesome. Thanks for being there. So this is the lineup for the State of Charge show right here. Has anybody met Chris from Felton yet?
Actually, I met him very briefly at Expo in Long Beach. He was hanging out with Jerome Andre. But yeah, I got to meet him for like a couple minutes. And also he's got his he was on Charge Heads UK. They had like a weekly podcast. Very cool stuff they're doing over there.
Nice. And then Paul Mangelsdorf, I don't know him. Oh, Amateur EV, looks pretty cool. Okay. Don't know much about that one. And then we got ReVolt's own Maddie breaking the land speed record. How fast was that vehicle? It was like 240 or something like that?
I think it was 214, right, Snow? 214 at 214.034. And we also got a video on Gas and Go with Snow and ReVolt Systems about that. Amazing stuff. Go check it out.
Let them in and not let the dog in. Cool. That sounds good. Check out this nice Lotus. We got a dual net gain. Tyler Willie. That's pretty cool. We got a Chevy C3100 Cascadia motors. And let's see. Okay. We also got a Nissan Skyline. I know people would lose their minds over this.
My God, we got to see that Skyline at Expo also. That was really cool to see it at Expo.
Oh, nice.
Kevin, what's up, man?
Hey, when and where is this show, first of all? Because the website seemed to say it was the 4th to the 6th with passed already.
Oh, no, this is coming up. This is literally in 2 days. Yes, this is Friday and Saturday. And I'm getting in on Thursday. And I'll be there. I'll actually be there a couple more days. It sounds funny, but there's another company paying me to learn how to seal houses because I'm a shop teacher. So there's another conference I'm going to learn how to use caulk. So there you go. But anyway, no, they're a great company. It's Sashco, and we're learning how to do sealing houses, energy efficiency with your house. Honestly, I've been saying this before, for real. The cars, the off-grid, the cars are part of the house off-grid systems, and Jehu knows that. Jehu, do more people buy your batteries for off-grid systems than cars, or vice versa, or you don't know?
Well, yeah, a lot of them I don't know, right? Because they just buy them and then I never get to hear what they end up. But I think traditionally I've sold a lot of batteries that don't work for cars. So, in the past years, it's been a lot of like storage applications and stuff, or small micro mobility like e-bikes and scooters and, motorcycles and stuff. But right now, since we're getting a lot of the modules for the cars, yeah, I think the conversion business side of our customer base is going to grow.
So I'm doing this Hyper 9 with 5 Tesla modules, but my plan in the future is to do the miniature Hyper 9, which is called the Hyper Mini.
Oh yeah, I saw that new one.
And that you can run. That's from NetGain, and Hunter is working on making it with. He has a 100-volt system, but he also has a 48-volt miniature Hyper 9.
Ah.
And from my understanding, would it be good to have a pack that's shared between an AC inverter for your off-grid, so you got power tools out the back, and then you share it with what drives your controller for the 48 volt Hyper Mini? Or would it be better to just run the 12 volt inverter off your 12 volt, and it don't matter, and you have a DC to DC? What do you guys think?
I think it depends on the size. Like if you want a big inverter, you know, you want to pull big power off the back of your truck or whatever, yeah, you probably just go straight to the batteries. Don't go through a DC to DC. That's more equipment, so then you'll need big equipment to get big. You know, you're talking about anything above 2-3 kilowatts. Now you're talking about, you know, big size and expensive equipment.
Yeah,
like
if you're wanting
Go
to
ahead.
run AC for a little while or anything like that, you know, if you're running off a 12 volt, you're probably getting what, 1, maybe 2 kilowatt out of a 12 volt inverter. No, those are for like running your fridge during emergencies mainly. Yeah.
So for instance, we just did a off-grid system at the high school. It's a 48 volt system, and it's got 2 Victron inverters, so you can actually run 240. But even just on one of them at 120, we can do, I think, 2,400 watts and a 3K spike. And we ran a welder that ran off a 110, and we were able to attack things on the frame from our own system, like welding the trailer that it's actually being powered from. And so imagine if you had a welder out the back of one of these mini trucks that we have here in the shop. That would be pretty cool. So I guess the size. So if you're going bigger than 3K, you're saying I should go right off the pack, right?
Right off the pack. And then with those Victron, by the way, if you're going to be running like an automotive pack, they tend to be going, they're very popular in 12S, right? So it's not really 48 volts. It's more like 44 volts nominal, right? So the only inverter, I mean, one of the few inverters that works is that Victron. So you're already set up with that. That'll run like, you know, like a small system, whatever that little system that you're trying to put on there. But it'll run also, you know, like if you put a bunch of these batteries, you can run up to, you know, 8 kilowatts or 16 kilowatts of AC power to whatever you want.
And Jason,
Nice.
Jehu, you have a 44 volt battery in stock right now, don't you?
All most of them are, yeah.
Or 44 volt, right?
Yeah. I got the Jeep ones. I got the Honda Clarities. Yeah, a bunch of. So it seems to be like a standard that is forming in all these car battery packs. They make them on these 12S modules or 6S modules. So, you know, you're like, oh, okay, 6S. Now you put the two of those together. Now it's 12S. So it seems to be a problem for the storage people, because they're like, hey, you know, it's like we want a 48 volt battery. You know, like, well, we can't do that with, you know, secondhand battery modules, EV battery modules, because those are 12S. So those are kind of 44 volts.
Nice. And so you think like I could run the drive system and the inverter system off the same pack?
Yeah, definitely. No problem.
Dude, less parts. Awesome.
Less parts. More efficiency.
Yeah. And then imagine if I keep the original wiring harness, that's 12 volt, but you just need a small battery to run the lights and a small DC to DC. That's pretty cool.
Lithium iron phosphate.
Oh yeah. There you go.
Yep.
Nice. Cool. I'm excited. So just going through the lineup, we also have this is Lauren and Sarah. They're like teaming up to make these Samurais. They want to rent them out. So it's actually similar. I think, Jehu, at one point you were gonna have like a fleet that you rented out, and
still working. It's just you know, working really slow. They might beat me to it.
I don't know. This is their first one. I think you're on number 10 or something. So, all right, we got a stealth drive system from Kevin and a 67 Chevy Camaro. It's so funny. The cars getting converted nowadays are like so sacrilege with all the pure hot rodders. But I love it. We're just hitting everything, dude. Like an 80s Lotus. We got the 50s truck and the 90s.
recently we filmed the electric conversion Jaguar here, and I believe it's the same company that did the one for the royal family. So stay tuned on that. We're going to see an electric Jaguar on the channel too. So
Oh, that's cool.
E-Type
That's
Jaguar.
cool.
yes, E-Type. Oof, oh my god.
The royal family, they take your tax money and they buy EVs with it. It's amazing. All right, so ABCs of EV safety. What's that about? Safety? Come on. So yeah, they're gonna have that there. That's pretty good. I guess I probably should go to that. We got a deep dive on vehicle control options. That's from Legacy, and this is Maverick. Maverick's gonna be on the show in August. He just confirmed. I think it's in later August. That's going to be pretty cool. And I think he's the CEO of Legacy. They do a lot of training and they sell kits. Keep your cool with Kevin Erickson. Erickson, man, is he related to Erickson Electronics? That thing, that company's been around for like 100 years. I don't know if this is the same one. Actually,
Kevin
that's
Erickson,
a good.
he's the one that did the satellite, right?
Yeah,
Yeah,
he's
yeah,
got the Dodge. Yeah.
Yeah, he knows his stuff. He's built one car right now, and he's building a second one, I think, right now. And yeah, he knows his stuff.
Yeah, he's got
Wait,
a large drive. He's got a large drive in the back of that.
What's the
Yeah.
satellite? What are you talking about?
It's that's the model of the car, right?
I believe
It's
it's
one
a
of these
Dodge.
really weird ones
It's
from
like
the
a-
70s.
It's sort of like a Challenger, right? Or
Like a Challenger body, same style, but it's a satellite, and he called it the electrolyte.
yeah,
Oh, nice.
This is a satellite.
yeah. That's
That's
one of
good.
the first videos on Out of Spec Renew. Features that car.
Nice. That is cool. Nice. Pretty cool. You know, I have a question about management, and actually Dave brought this question up about the cooling and heating.
Oh, I was just thinking about that. Yeah.
Okay, so I've never set up a cooling or heating system. Most of the projects I've built are like in an educational environment. So they kind of go to like a car show under ideal conditions. What do you guys think about heating or cooling the batteries? My question, I know you do have to heat them so that you can't charge below 32, is my understanding. But the other thing is, if you cool it, how do you stop condensation from building up in your box? Has anybody thought about this?
And we're talking East Coast, not right, because most of you guys are all on the West Coast.
Yeah, what do you do? Well, they still get a little humidity though. Jehu, no, nothing. Okay. Jehu, have you ever heated or cooled any of the batteries you put on the cars?
No, because I've always done little systems, right? So up until now, I've done 80 kilowatt systems, and we're putting batteries that are used to doing 380, 400 kilowatt systems. So I'm like, you don't even want to cool them. Like, why? Like, they never get hot. I mean, other than sitting there in the sun or whatever. But they're never getting heated by use. We're never charging them fast, right? Because DIY still can't supercharge. I mean, they're kind of starting to, but in the past it hasn't been a thing. So as of right now, we don't. But look, this is a cooling plate that we're taking from a Honda Clarity, and every single one of these cars has some kind of cooling plates. And up until now, they've been going to basically to scrappers, but I'm saving them now, and I'm trying to figure out which packs they work with, and all this stuff. It's all figured out here for you. They have quick connects. It's all OEM quality stuff, So this stuff is coming. You're gonna be able to kind of choose which cooling plates you're gonna be able to use and stuff, and right.
To be honest, there's not much popularity on the East Coast yet. It's not like out there in the West or in Colorado and stuff, but it's happening. And so now here comes Dave, new to the scene, and he's asking, well, yeah, I got to cool and heat the batteries, but you have a lot of connections. What if this device you have reduces the amount of connections you have? That would be interesting, right?
I think your condensation question is a bigger concern.
Okay.
Right? Just because of it's gonna get hot, it's hot out, you're gonna cool your batteries. And if you're using a Tesla, you're gonna go through the Tesla. Like, why would you add to that, right? You can just go through the cooling system.
If you had it, right.
Right. But I think the condensation is a legit problem.
Well, on the call tonight, Eddie is right here, and I know Eddie did use the cooling. So, Eddie, you want to tell us did you guys heat it, cool it? What for, and how did you do it?
For on the Tesla modules, what are you asking about specifically?
Well, in general, should we heat? When do we want to heat, and when do we want to cool? And how did you guys do it?
I mean, the optimal temperature of these batteries is anywhere between 25 to 50 degrees C. You don't want to kind of go anywhere below that if you want any kind of performance, and anything above that. I mean, the hotter it is, the better for performance. I mean, if you can get these things to like 60 degrees, but you didn't hear that from me. Like, you're starting to play in some really dangerous territory. And if you're monitoring your batteries, placement of your thermistors is extremely crucial. The inside of your battery pack is going to be a lot hotter than the outside of your battery pack. It's just mass. And Jehu will tell you, he moves a lot of batteries. They weigh a ton. And when you have that much mass, moving temperature around becomes extremely difficult, especially when you have multiple cells. So when it comes to cooling, I mean, it's not like you're cooling them to the point that you're going to condensate anything, because you're keeping them like our bodies. Our bodies like around 75 degrees. That's what we like. That's what batteries like. So if you could keep them in that, anywhere between 30 and 50 degrees C, that's kind of the upper and lower level for good performance. Even down in, up to like 15 degrees, down to 15 degrees C is fine. When you start getting to closer to the zeros, that's when the batteries are going to really kill you on performance. You want your batteries warm. If you live in a cold environment, you want to warm them up. You want to get them up around 15 C. Just because they degrade down there, they don't have a lot of power down there, and you're going to be just hurting things. That's why Teslas hate the cold. It's like we hate the cold. You'll go through a whole battery pack really quickly driving through snow, because it's just, there's a lot of radiant temperature coming off the bottom of the car. But that's kind of the window where you want to keep things. Condensation, we haven't run into that. I mean, we don't get too humid out here, but you're not chilling the battery down to a point that's so cold that you're attracting moisture to it. You're just keeping it in a very happy kind of place. We live in a very good environment. Jehu knows that too, because he's out here with us. We don't really need the heat or chiller batteries really in Southern California. If you're just putting around, having a decent time, you're going to be okay. But that only works in certain demographics and regions like where we're in right now. For instance, my Mustang, we have Tesla, like I said, Tesla pack in there. That was a temporary pack. I put that in for SEMA. Somehow it came somewhat permanent. It's been with me now for 2 years, a year and a half. I do not have any cooling going through that car or heating. I play a very dangerous game. I do not recommend this to anybody, but I have, big monitoring systems. I'm a geek. I got everything on my panels. I just took my car up a very heavy grade the other day, Palmore Mountain. It's about 5,000 feet of ascent. I'm on the throttle, almost wide open the entire hill. So I'm killing the hell out of that thing. Battery got about 50, 55 degrees at the top of the hill. That's with no cooling. And I had to wait about 2 hours for everything to cool down, because on the way down is the problem. Is regenerative braking will put so much more heat into your battery than cooling. Going back into the battery generates a tremendous amount of heat, because you have extra resistance packing all those electrons back into the battery.
It's basically supercharging, right?
You are supercharging. When you're regenning on like a large drive unit, you can leave that open, Snow. On a large drive unit, you're going to be regenerating about 60 kilowatts at full tilt.
Wow.
Yeah, so it's a ton of stuff going bad. People don't realize that, and all of a sudden they're going down a big hill and their batteries explode on them or catch fire because they have no cooling. Well, it did just fine going up the hill. Well, why did it blow up going down the hill? Well, because you're putting that stuff back in, and that's where the resistance really kicks in. So cooling is extremely important. I think it's more important than heating, especially for performance stuff. But you do want to keep your batteries happy. Jehu's dealt with this for many, many years. Lithiums are very sensitive to temperature. And I've seen, even at Bonneville, our first run during one of our record hits was like, I think we had a 8-mile-an-hour difference just by the temperature of the pack. That was it. Because the first day we took off, we were there on a cold. Yeah, we were there on a cold pack. It was cold. It was October. It was like 40 degrees outside. And we ran in the morning. The battery pack was fairly cold. We ran it, and then we put a blanket around it that night. And the next day we ran it. It was sitting around 70 degrees versus 40. And we picked up about 8 miles an hour. So it is important. Tesla does something called conditioning. So when you go into the superchargers, if your battery's cool, it'll actually warm up your battery. If your battery's too hot, it'll keep it mitigated as well. It won't let it get over 55 degrees C. My Tesla is unlocked. I have something called developer mode running on my screens the whole time. So I'm able to track all these thermal management systems and see exactly what Tesla's doing with their batteries. Guys, they spent billions of dollars on this. I just copy what they do. And
you're gonna put that on my car, right?
Yeah.
I want to see my cells.
So it is good to kind of mitigate that. But there's a lot of different types of cooling. Don't underestimate cooling and heating. It's absolutely crucial. Jehu will back me up on this one. This is a really easy way to screw up something that's the only volatile part of your vehicle is the batteries. It's the only part that's going to catch fire. It's the only part that's going to cause people to get electrocuted and hurt. So you got to treat those things very, very carefully. Also, when you're designing cooling systems, batteries, like I mentioned before, they're massive, lots of mass. And if you got a lot of cells stacked up together and you're just running cooling around the outside or a chill plate underneath, you're not really wicking a lot of the heat away. Yeah, those things have serpentines going through them. And that's not even Tesla's best solution for cooling batteries, but you want to be able to remove the heat equally. The outside of your pack is always going to be cooler than the inside of your pack, no matter what you do. We do something called submersive cooling here. We're developing a new battery race pack right now, and it's all submersive cooling. So what we're doing is we're using a dielectric fluid to fully flood the batteries 100%. So we're cooling we're cooling the bus bars, we're cooling the 100% of each cell, and the casing, everything. And what that does too, over time, when your cells are warming and cooling throughout your drive cycle, the inside, as I said, will get hotter and the outside will not be as hot. So the degradation of those cells is going to even change per module, because the inside of the module may degrade faster because of heat, or slower depending on what your driving conditions are. So it's really, really, even if you're not worried about hot or cold, back to my Mustang, my front battery packs are exposed to the air coming across the front of the car. The rest of my battery packs are my floorboards or trunk. My trunk tends to get very hot during the day because it's out in the sun and has no airflow over it. The inside of my car stays pretty cool, and underneath the hood stays pretty cool. So when I get in my car and I turn on my car, the delta T between the rear pack and the front pack is like 10 degrees C. That's tremendous. So when you have cooling systems, when we did Tim Allen's car, we do every car, especially this one behind me, we're not worried about cooling the pack so much here as we are worried about making sure that all the cells are the same temperature. It's going to help with your battery management systems and the life of your cells.
And you recommend that for cars that are not doing performance?
Yeah,
right?
I mean, you got to get your temperatures of your cells equally balanced throughout your entire car. So as I said, you got
it's not just the battery management. You need liquid cooling management.
Yeah, you want to make sure. Yeah, and I would recommend people not to use coolant like ethylene glycol or G48 for their battery packs. I think it's a really bad idea. Tesla's an OE. They stress test everything. They do things a lot better than we do. The OEs, they have more money. We're doing this kind of conversion, sticking Tesla cells in it and hoping for the best, which is no leaks, right? They're going to leak. Something's going to go wrong. We haven't had a single car come through here that wasn't leak proof. So what I'd recommend everyone doing, and this should be industry standard, if you're going to be passing cooling through batteries, even if you're not using immersive cooling like we are, but if you're doing just regular cooling, use a dielectric fluid, mineral-based, or something that cannot conduct electricity. There's 3M makes a really good one. I got a couple other ones that I use. It's not the cheapest stuff, but it's actually kind of comparable in price to like G48. It's extremely expensive. But what happens if your battery does leak or you develop a problem later on down the road and it floods your battery pack? It just happened to Will the other day. He was testing the Volkswagen that he's building and he had a leak and he goes, "Thank God I used your fluid, because if I didn't, that G48 would have gotten down inside the Tesla cells and flooded them, and who knows, caught fire or destroyed the cell at that point."
One of the things that happens is they corrode, right? It's very corrosive. It stays in there and it like just destroys those modules. It gets the little fuse links and just kind of eats them away. And so that's it. Your pack is done just because you suffer one little leak.
Yeah, Jehu hit it in the head. And Jehu, that happens almost instantly. I mean, overnight, that could develop into a pretty bad problem.
Yeah, a lot of the times, customers will be like, "Hey, I have these modules here. Can I use them?" And you're like, "Yeah, I think so." And then they go, "Hey, I don't know, no voltage." And then I go flip them around. Are they wet? Yes, those are done. Get new ones.
Trash.
So-
So yeah, no, very careful.
Drains on your packs on your. So if anything leaks, it drains out, or you just hope that it doesn't leak, or you just because you're using dielectric fluid, you don't worry about a drain.
We do put one-way valves in some of our packs. So it's just basically a one-way purge valve. I do put inspection plates on the bottom of my battery packs. So especially, we want to know if something's wrong.
Yeah.
So we do put inspection plates in there. So when the car comes in for, any kind of maintenance, we could pop one of those inspection plates over, take a look inside. And also you're monitoring your fluids. The coolant loop on the batteries, we always split that off. That is never on the same coolant path as the motor or anything else. That is
Okay.
always.
That was going to be my other question. And then I guess from the sound of it, you're splitting your coolant loop. If you have a front and a back, you're going to split your coolant loops. So you have one for the front, one for the back, so you can change your temperature depending on you don't.
No.
So then how, like saying in your Mustang, you got 10C difference. So how do you manage that? Because if you had to split,
He didn't put coolant on the Mustang, but in the other cars he did, right?
My Mustang is anomaly because those batteries were temporary, and that's why we see those problems. It's a perfect reason of what not to do what I did. Once again, we're a shop. We pretend we know what we're doing here, but there are corners that I cut with that car because we needed to get it to SEMA, and I just never updated it because we don't live in an environment that has that many problems. So with that said, don't ever do what I just did. You want to mitigate, but this is why we're seeing those big deltas because things aren't done properly. And once you start doing that kind of stuff, you're just asking for trouble. Luckily, I know how to mitigate this stuff, but I did get stuck up on Palmer Mountain for 2 hours, which was pretty because it was nice sunset. But you just don't want to do that kind of stuff. You want to keep your temperature loops. Your batteries should be all manifolded together and never, ever run them in series. Always run the coolant in parallel. So if you have 16 modules, you don't pump module 1, then to module 2, 3, 4, because by the time you get to the end, your heat's going to be insane. So you want to run them as a manifold. You have one big pipe running down the side as your inlets, and another big pipe on the other side running your outlets. So you could transfer all that heat out. Just like Jehu's, look at what Jehu's showing you right now. Perfect.
And the
Jehu, what's that?
That was from a Clarity.
So that's
this is the cooling plates from a Honda Clarity. Every car that we're dismantling and getting modules from will have a cooling plate. Some of them are built into the pack, like the Volkswagen packs. They're built into the battery casing, so we can't use those. But a lot of them are, separate parts like this that we can take out and we can redesign a different box, and you can reuse them.
Nice.
Yeah, and so this is exactly what Jehu was talking about too. So this is the inside manifold from a Tesla Model X. As you can see, there's a little 45 bar that comes off of every one of these things. So this is the inlet for one side of the battery pack. And there's another one like this right next to it for the outlet. So this main line feeds every single module. So this is called parallel. You never want to run them in series. So it's kind of a really big deal.
Nice. Cool stuff.
I just want to
Dave, Steve's got another question.
I got a lot of questions. I'm just curious why you said you wouldn't run your back and your front packs separate, right? From a coolant point of
Because
view.
you want them to equalize.
But wouldn't you equalize that with by changing the temperature in the coolant or heating, however you're doing
Well,
it?
then you got two different systems, but they might be slightly different, right? I would say just run them the same.
So then it's going to take longer to get the ones that are in the back that are colder, let's say.
No, in parallel, not in series. So they're being cooled at the same time.
Right, but the ones in the front, let's say, don't need to be as cold. So they're getting part of my coolant. They're going to not need to get it. And by the time it's coming around to the back, which needs more because it's hotter for whatever reason.
No, but it's in parallel is what he's explaining. So everybody's getting the same feed.
Understood, but like my front doesn't need it, let's say. So you're just kind of like, it is what it is.
Yeah, they're going to be equalized. Yeah.
Yeah, you don't want to play that game of splitting stuff up. That's just asking for major problems. Keep everything on one cooling loop, parallel all the batteries together. Run
It's
a
not
big.
going to be perfect. Yeah. These are good. Like he's new to it. So these are great questions because it's like if a beginner has a question, like so does everybody else. Me too. I haven't done any cooling either. Now with the Tesla cells, would you use the loop that the coolant jacket that they have in there, or would you do something different?
No, they'd spend millions of dollars developing that. Don't touch it.
Yeah. Okay.
they
Tom
have more money
Summers
than
has
we do.
got a question. Oh, sorry, Eddie.
Okay.
Tom Summers
They have
got a
more-
question. Patiently, go for it, Tom.
Yeah, I just I think that's really great that we went down this avenue here. And thank you, Eddie, for sharing all this stuff. The first thing I was just going to throw out there is that's a good reason why we put an on-off switch on our regeneration. We just find it out the hard way that if you're fully charged at the top of the hill, well, you shouldn't be. But anyway, the other thing that I really wanted to point out, and I think you and really all of us are probably going to be affected by the future landscape of regulation. And especially if we want to, or if you guys want to go into business and sell stuff, it's got to be standard. There's got to be a certain standard that they're going to impose upon us. And honestly, I'm not looking forward to that. I think these are the good old days of the way Jehu has kind of brought us up, which is like, make it work. And as long as the state doesn't ask any questions, the DMV,
Just wing it.
Wing it. Thank you. Anyway,
Well,
love you
look,
guys.
Yeah, no, it's awesome, Tom. Thanks. And Tom's bringing in the Volkswagen scene with Jehu Garcia and whatnot. But yeah, I mean, to me, it's just hot rodding. So it's we're not reinventing the wheel here. We're just putting big OEM stuff in small cars. So it's like it's the same thing they did after World War II, when all the aviation scientists came back and they had some time on the weekend. So pretty cool stuff.
It's funny that you say that. Oh, sorry, Jehu, go ahead.
Oh, unmute yourself, Jehu. Go ahead. Oh, Jehu, unmute. We can't hear you.
Oh, sorry. I thought I was muted. I have to go. It was really nice talking to you guys. I'll join here next week also. So
good seeing you again, Jehu.
Okay. Hope to see you at State of Charge. If you do, let me know. Okay. Pretty cool. Yeah, we're getting on to the 1 hour mark. We're gonna. I wanted to show you the K truck a little bit, and we had some questions about building. Yeah, cool. So let's just quickly finish the State of Charge, and then we'll hit the K truck real quick, and then we'll wrap it up. And if anybody has any questions, go ahead. Let's see. So State of Charge. We also got. We talked about that. EV conversion kits. That's Current Motors. I think I met them before. I think they're down in Austin. Pretty cool. I might be wrong about that. The Leaf Whisperer. Hey, using the OEM motors is going to be real popular. Leaf motor and what comes up with that would be pretty cool. Tom Summers got his hand up. Go for it.
Yeah, I almost forgot. And thanks for reminding me. Omar, I think it's Omar Sevilla from Madison High School, the shop teacher.
Yeah.
Anyway,
he's. Yeah, this is a different Omar, but there is an Omar that's running a really good high school program, and with the help of ReVolt, we just did a conference out there. That was awesome.
Yeah, that guy. He is addressing us at the EVA monthly meeting tomorrow evening at the San Diego Automotive Museum, which is always a good excuse to go get some free pizza and listen to interesting people.
Nice. Awesome. And let's see, beyond the one-offs. Oh, repeat builds. That's very interesting. Oh, these guys are in Colorado. They're actually in Denver. I just saw an interview with them from Out of Spec. And then Q&A with the experts. I don't know how, but they're going to put me on that panel as an expert. But I'm coming in from the education space. I've done a whole bunch of education builds, and I think I got a good formula. So if you're in the education space, if you're a teacher and you want to do a project, make sure to talk to me, because I think I figured out that education space, how to get it done quickly, less stress, and also empower the students. You really got to let the students empower themselves and let them be in charge of a lot of the project, and that would really help out. Okay, I think that's it for Ohm on the Range. There's a happy hour, and that's pretty much it. Pretty cool for that. So let's go over to the quick mini truck tour, and then we'll wrap it up. What do you guys say? All right, Talik, hold the fort for a sec.
Again, who here is gonna actually make it out there for that? I was originally planning to go, but the week just swing, getting a road trip out to Colorado this week wasn't gonna really work out for me. Definitely would love.
Yeah, I was going to try to twist your arm and so forth, but I realized I'm not going to be back in time anyway, so I can't.
Tom, what's up?
Oh yeah, Talik, I was actually going to invite you to road trip with me. You could be I could be your co-pilot. You could drive my car.
Yeah, unfortunately, it's some other things kind of popped up this weekend. In fact, this whole team is going to bring a bunch of classic cars out to Cruising Grand and Escondido this week, so I kind of need to be on the site. So I think Ron's about ready to show us the truck.
Yeah, and we have a lot of questions, but it's late in the episode, so we're going to save these questions maybe for next time or the week after. But this is your Hyper 9 setup, and then over here, I actually do not have a coupler. This engine, the engine is literally right there. And I wonder if you could see it even from under here. The main thing I want to show real quick is that I'm going to take the crankshaft out of the same engine. I went and ordered this from an engine rebuilder, and we're going to make the coupler. You want to grab the coupler off the table? And then we're going to hook it up to the Hyper 9 motor shaft. So we're going to put it on a lathe. I'm going to make it look like this. This is from a Volkswagen, but it's going to be similar like that. Then the other part is we got Tesla cells for this. And we're going to run 5 Tesla cells, motor modules, and we're going to put them right here. And then this board is going to be everything from here. So we're not installing it in the vehicle like every little nook and cranny. It's literally going to be laid out so you could see everything. And that's what we're doing. We got a lot of questions about this. I wanted to ask about using a stated charge with a shunt versus using it on voltage, but it's late in the show. So what we're going to do is we'll just do that in the after game. If anybody's got a suggestion, if anybody has the adapter plate for this engine, this is the Daihatsu Hi-Jet from 1999. And I do not have the adapter plate. And I don't know anybody that sells it. So please reach out to me. I'd rather buy it, but if I can't buy it, I will make it. We're in the process of getting it made by doing like a hammer technique. We're gonna make an imprint and then put that in the CAD and get it cut and send. Anyway, that's it for that project. And let's wrap up the video here. All right, cool stuff. So yeah, thanks for coming around. And maybe next time we'll go over to see Abe's 280Z that we're going to put a ReVolt system in. We'll do it right here. It's going to be right here in the fall, maybe, hopefully. All right, cool. So let's end the recording right there. And yeah, it looks good. Thanks for everybody joining us. State of Charge is the next one. And then we also have a bunch of people coming into the show coming up. Kevin's got a question. Go for it.
Well, I had lots of questions on your K truck, but do you have the engine out already, or you're?
Say again?
Do you have the engine out already?
No, not yet.
Okay. And how hard is it to cut a crankshaft? I've always wondered that. It's got to be the most hardened thing.
Okay, that's what I thought. I've cut in a crankshaft on a Chevy 350. It is soft. No problem. That's what I thought. Yeah, you can cut it with a bandsaw. You lop off the end.
For real?
Yep. I thought, no way this is going to work. Nope, totally. You can cut it. You can machine it. No problem. Maybe the outside is hardened. I'm not sure.
But once you get
it, it's cut.
You can get past the crusty outside. It's nice and soft. Okay.
It's kind of like me. It's I got a crusty outside.
We're not going to put you on the bandsaw. No way.
Yeah, just throw me on the bandsaw. Make me bandsaw adjustable. That's something my old shop teacher used to say at college for product design. I'd make it adjustable. He's like, just make it bandsaw adjustable. This guy was from Boston. He'd be like, just make it bandsaw adjustable. Anyway, all right. Any other questions on the K truck?
Yeah. Hey, I was just gonna say I'm gonna be following this build pretty close. You're you're incorporating a lot of the things that I'm interested in regards to a central location for all of the accessories, and that's kind of my fantasy with this Volkswagen, flatbed project. If it ever gets off the ground, I just feel like I really need to get the bus back together first before we start anything else. But that's another story.
Yeah, that would be really cool. I think the bus is a great learning example, and that's a question we should do. I think we should do like an episode on EV build questions, because
Yeah.
I've got a list. Which contactor, what type of economizing or external, internal? I knew the answer, but that's a good question. Why do you have to have equal length wires? And a big one is the state of charge. Do you use a shunt and count the amps, or can you just check the voltage? There's so many questions about the pre-charge resistor, pilot proximity, parasitic draw. Do you put Anderson connectors into your wiring diagram, or you leave them out? Where do you put connectors? Why do you put connectors? There's so many. It's just so many.
So many.
Yep. And so we'll do that whole thing maybe in a week or two. Cool. All right. Let's end the recording right there. And this way it's a watchable episode. We don't want to go too far past an hour. All right. And we'll hang out for a minute. Let me just end the recording. Thanks everybody being here, and we'll see you at State of Charge.